Today we're going to look into Pure Maths 3, October November 2024, variant 2. Okay, so let's begin with question number 1. Expand 9 minus 3x power of half in a ascending power of x up to including x power of 2. Simplify the coefficient. Okay, so here the first thing is the power here is actually non-integer. Okay, so we will follow the binomial expansion from your formulation. If you look into, it's going to be 1 plus x power of n, where n is a non-integer, or it can be it's going to be 1 plus nx plus n minus 1 over 2 factorial x power of 2, and so on. This one you can get it from your formula booklet. Okay, so if you notice here, this is 1, whereas for this case they give me 9. So I factorize the 9 outside, so it's going to be 9 bracket 1 minus 3 over 9x power of half. So we can rewrite this as 9 power of half bracket 1 minus 3. So 3 over 9 we can simplify as 1 over 3. 1 over 3 x power of half. So it's going to be 3 bracket. So now we expand this. So here my x is actually negative 1 over 3x, and your n equal to 1 over 2. So it's going to be 1 plus n x plus n minus 1 over 2 factorial multiply with negative 1 over 3 x power of 2. Okay, so it's going to be 3 1 minus 1 over 6x, and you simplify this, you will get plus 2 over 9 sorry minus 1 over 72 x square. So it's going to be 3 minus 1 over 2x minus 1 over 24 x square. Okay, so this is your final answer. Okay, question number 2. By a sketching suitable pair of graph, show that equation cot 2x and secant x has exactly one root from the interval 0 to 1 over 2 pi. So we must know how the cot 2x graph look like. Okay, so my cot 2x, maybe I just draw. So my cot 2x will look something like this. So this will be y equivalent to cot 2x, and secant x will be looks something like this. Okay, so we can assume here is pi over 2. Okay, and here you can see there is only one intersection point, so you can say it, since there is only one intersection between the graph y equal to cot 2x and y equal to secant x. So we just label this y equal to secant x. Therefore, there is only one root between 0 to 1 over 2 pi. So you can add up this thing. Okay. So make sure you give some justification why you say it is only one root. So the justification here is actually because there's only one intersection point. Okay, now show that if the sequence of real values given by the iterative formula is x n plus 1, this is converge. So means they are saying that this equation is converge. Then it converges to the root of part A. So means it also converges to the root of part A. So what you can do here is the two ways. Either you bring this equation to this, or vice versa. Means I can rewrite this equation in terms of the earlier equation here. Okay, I can write in this form. So it's going to be, for the first step, I can say that I let my n plus 1 and n as the same. So x equivalent to 1 over 2 arctangent cos xn. So it's going to be 2x equal to, so I can introduce tangent in front. So 2x tangent equal to cos x. So it is cot, so 1 over. So cot 2x equal to secant x. So since I can write this expression into my earlier equation, means this also converge. Okay. So now let's go to question number 3. The square root of x minus 8. So they are given you the equation is here, can be written as a Cartesian form x plus yi, where x and y are real and exact. So take note, they are real and exact. So by first forming a quartic equation. So quartic equation means you must form a equation with x power of 4. So that means by quartic equation. Okay, find the square root of 6 minus 8i. Okay, so from the equation they said the square root of 6 minus 8i is given as x plus yi. Okay, so squaring both sides, so 8 minus 6 minus 8i will be x plus yi square. So you expand this, will be x square plus 2xy plus y square I square. So if you know I square equal to negative 1, therefore it's going to be x square minus y square plus 2xyi. Okay, so now you can see you compare your real part and imaginary part. So here this is your real part 6, and here your real part is x square minus y square. So by comparing, x square minus y square equivalent to 6, whereas for my imaginary part negative 8i to yi. So we just take the numbers or integers, so it's going to be 2xy equivalent to negative 8, therefore y equal to negative 4 over x. Okay, so you can take this, you sub in, it's going to be x square minus negative 4 over x square equal to 6. So x square minus 16 over x square equal to 6. So if you rewrite, it's going to be x power of 4 minus 6x minus 16 equivalent to 0. Okay, so you already formed the quartic equation x power of 4. So you can write in x power of 4, or you also can put y power of 4. It doesn't matter because you said x or y, it doesn't matter. So you can substitute y also. Okay, you should get the same answer. So by factorizing this, so x square minus 8 x square and x square plus 2 equal to 0. Therefore, x square equivalent to 8. So your x equal to plus minus square root 8 is 2 third 2. Whereas here x square equal to negative 2. So this one we cannot proceed because it's a square of any number, we won't get the negative. So it's not cannot be proceed. Okay. So when x equal to 2 third 2, my y is equivalent to negative third 2. You can calculate. Okay. When my x equal to negative 2 third 2, so my y will be positive third 2. Okay. Therefore, square root of 6 minus 8i will be plus minus x is 2 third 2 minus third 2i. Okay, so means when x is positive, y is negative. When x is negative, y is positive. Okay. Question number 4. Solve 5x. Okay, so you need to solve this equation and give the answer to correct to 3 decimal place. So take note on this. So for this, 5x is equivalent to 5. I break this x plus 2, so 5x multiply with 5 power of 2 minus 10. So if you want, you can let your 5 power of x equal to u. So I just put let 5 power of x equal to u, so it's easy for you to calculate it on. But if you don't want, you want to let like this also can, doesn't matter. So 5, sorry. So u equal to u times 5 square will be 25 minus 10. So you rewrite 24u equal to 10. So u equal to 10 over 24. So 5 power of x equal to 10 power of 24, because the u here is actually 5 power of x. So I introduce ln both side. So ln 5x equal to ln 10 over 24. Therefore, you can bring the x in front, so x will be in front there. So x is equivalent to ln 10 over 24 divided with ln 5. So you can press a calculator and you will get negative 0.544. Because the question here specifically mentioned correct to 3 decimal place. Okay. Question number 5. The complex number u is given by this. Find the exact value of argument of u. So if I notice here, there is a denominator here, which is cos 1 over 7 minus I sine 1 over 7. So what I do, I multiply with the conjugate first. I multiply this with conjugate, cos 1 over 7 pi minus I sine 1 over 7 pi over cos 1 over 7 pi plus I sine 1 over 7 pi. I multiply the conjugate, okay? So that denominator there can have a real number. So what happened here? Your u will become cos 1 over 7 pi plus I sine 1 over 7 pi power of 5 over cos square 1 over 7 pi minus I square sine square 1 over 7 pi. As I mentioned, my I square equal to negative 1. So what happened here? The denominator will become plus. So cos 1 over 7 pi plus I sine 1 over 7 pi power of 5. So it's going to be cos square 1 over 7 plus pi sine square 1 over 7 pi. So cos square plus sine square will be 1. So you will have my u equivalent to cos 1 over 7 pi plus I sine 1 over 7 pi power of 5. Okay. So here you can say that the argument of cos 1 over 7 pi plus I sine 1 over 7 pi is equivalent to 1 over 7 pi. Okay, this is what we know. Okay, because it's in this will be the argument. Okay, and if you still remember, argument of u v will be argument of u plus argument of v. So in this case, if I said argument of u times u, so u square, this will be argument of u plus argument of u, which is equivalent to 2 times argument of u. So since here is x is here is power of 5. Okay, so power of 5. So I just assume this as a v. Okay, let this is a v equal to cos 1 over 7 pi plus I sine 1 over 7 pi. So if you want to find argument of v power of 5, correct? So it's equivalent to 5 times argument of v. Okay, so my argument of u is equivalent to 5 times 1 over 7 pi, which is 5 over 7 pi. Okay. For b, the complex number u and u prime is plotted on an Argand diagram. Describe the single geometrical transformation that maps into u onto u prime u star, so and state the exact value of argument of u. Okay, since we don't know what is the what we call since we don't know what is the u's x and y, so we just assume my u is equal to x plus y I. Therefore my u star will be x minus yi. It will be something like this. We just assume. So my x can be positive or negative. It doesn't matter. It will give you the same, no matter what. Okay. So for this case, I just assume my x is positive. So if my x is positive, so what happened? This will be my u. Okay, and here will be 5 over 7 pi. And for this, it will be here. This is my u prime, u star. So it will be negative 5 over 7 pi. It must be something like this because they are sharing the same angle. So this will be the u and this will be my u star. So the geometrical transformation will be a reflection on x axis, and the argument u star will be negative 5 over 7 pi. Okay. For question number 6, it is given that the variable x, y satisfy the equation ay plus bx, where a, b are constant. The graph of y, ln y against x is a straight line passing through these two coordinate. Show the diagram. Okay, find the values of a and b. Okay, so if you notice, this is a linear graph and this is a non-linear. So we convert the non-linear into linear first. So maybe I can use multiply ln both sides because here they gave me ln. So it's going to be ln ay equal to ln bx. Okay, so it's going to be ln a plus ln y equal to x ln b. So I rewrite, so ln y equal to ln b x minus ln a. So from here you can say my gradient, which is m, normally we said is a ln b. Okay, so how to find the gradient? You can use these two coordinate to find the gradient. So it's going to be y2 minus y1 over x2 minus x1 equal to ln b. Okay, so your b will be 8.0. You can calculate this, and for this it is a y-intercept, so you also can directly substitute this inside. So it's going to be, this is x and this is ln y, so it's going to be 2.24 equivalent to x ln b minus ln a. So x here is, I'm sorry, so x just now is 0.5. Therefore your ln a will be ln 8. So will be negative 1.2003. Therefore your a will be 0.3. Okay, since the question here mentioned they want the answer correct to one significant. Okay, so I give you the one significant figure. Okay, question number 7. Show that the equation of tangent cube x to tangent x minus tangent x equal to 0, expressed as tangent power of 4 minus 2 tangent x plus 3. Okay, so for this, what I can see here is actually, here it is x, here it is 2x, and here it is x, and my final answer is in term of x. So what I do, I change this into x first. So tangent cube x plus 2 tangent x over 1 minus tangent square x. So you can get it from the formula booklet, this one. So you can directly take from there. Okay. And then I multiply the equation with 1 minus tangent square because I want to eliminate the denominator. So it's going to be tangent cube x multiplied with 1 minus tangent square x plus 4 tangent x minus tangent x multiplied with 1 minus tangent square x equal to 0. So tangent cube x minus tangent power of 5x plus 4 tangent x minus tangent x plus tangent cube x equal to 0. Okay, so negative tangent power of 5 x plus 2 tangent cube x plus 4 minus 1, so plus 3 tangent x equivalent to 0. Since all the terms here I have tangent x, so I factorize negative tangent x, so will be tangent power of 4 x plus 2 tangent square x, it's not minus 3 equal to 0. Therefore negative tangent x equal to 0, and tangent power of 4x minus 2 tangent square x minus 3 equal to 0. So based on this, tangent x is cannot equal to 0, so this one we can reject. Therefore we have only this. Okay. B. Hence solve the equation of this. So if you notice here, over here is 2 theta, 4 theta, and 2 theta. Whereas the question here is gives you x, 2x, and x, which means now my x become 2 theta. So instead of this equation, I can use this. So it's going to be tangent power of 4, 2 theta minus 2 minus 3. Okay, minus 2 tangent square theta. Sorry, 2 theta minus 3 equivalent to 0. Okay, so we factorize them. So tangent square 2 theta minus 3 tangent square 2 theta plus 1 equivalent to 0. So tangent square 2 theta equal to 3, and tangent square 2 theta equal to negative 1, and this one is not applicable because tangent square negative is, you cannot get the negative when you have square any number. So over here tangent 2 theta will be plus minus 3. Okay, so usually I find the reference angle, so reference angle will be 1 over 3 pi, and since here is 2 theta and here is theta, so it's going to be 0, 2 theta, 2 pi. So my 2 theta value is going to be all 4 quadrants: first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, because they do have plus and minus, so it include all 4. Therefore 2 theta will be, first quadrant will be 1 over 3 pi, second quadrant 1 minus 1 over 3, which is 2 over 3 pi, third quadrant will be 1 plus 1 over 3, which will be 4 over 3 pi, and the fourth quadrant will be 2 pi minus 1 over 3. So 2 minus 1 over 3 is 5 over 3 pi. Therefore, my theta, you divide everything with 2, will be 1 over 6 pi, 1 over 3 pi, 2 over 3 pi, 5 over 6 pi. Okay, so you can notice my theta value, my final answer is all 0 to pi. It is not exceed the pi. Okay, so please take note, the common mistake that students will do is actually here. When they do the square root, they only include positive set 3. So then you will only have first quadrant and third quadrant. So please take note, whenever you have a square, you bring the square root, so it must be plus minus. Okay, and then you can find the reference angle and move on with that. Okay, so that's all for this section. Thank you.